In this tutorial, we're going to look at a few more annotations. This is the model class that we wrote in our previous tutorial. Let me remove all these extra configurations so that we are left with just the basics. Okay, so now this model class has an entity annotation and an ID annotation, and we have two member variables. Now we'll look at a few more annotations here. First of all, we have an annotation called at table. So I'll import the table from Java x.persistence. Now this add table has a property called name, and I can use this to set the table name. Now, how is this different from what we saw in our earlier tutorial? In our earlier tutorial, we controlled the table name by using @entity and name equals the new name. The way it's different is by you providing a name for @entity, you are providing a new name for the entity itself. But by providing a name for the table annotation, you're just providing a name for the table which is created for the entity, while the entity name still remains the default class name, which is user details. Now, when would you need to know the entity name? When would you need to call the entity name versus just a table name? We will learn about that when we are writing HQL, which is the Hibernate queries, where you'd want to address the entity name and you wouldn't be addressing the table name. So if you want the table alone to be having a different name versus having the name changed for the entity itself, then you would leave entity annotation as it is, and you would change the name only for the table by using the @table annotation. Okay, now we saw the ID. Let me add a few other properties here. I will need to import the date from java.util. Now I have declared a few more fields. I will generate getters and setters for them since they're all private. It's for these three fields. Okay. Okay, now what I'll do is I'll initialize these values in my main method and then I'll try inserting this. Let's see what happens. I'll use user ID 1. This is first user. Let me fill up all the other properties as well. User dot set address. Set join date. I'll just use the present date just for testing. What else is left? The user, the description. Okay, so now I have filled in all the values for the new fields that I have entered. So let me just save and run this. We'll see what kind of a table Hibernate creates for us. Okay, so it just created this table and inserted the values. Let's have a look at what it's done. Again, I'll have to do a refresh because the whole schema has been recreated. Okay, there you see user details table is what's been created with 5 columns. Now, if you have a look at each of these columns, user ID has been created as an integer. Address has been created as a varchar of 255. Description is a varchar 255. Join date is a timestamp without time zone. Username is again a varchar 255. Now, these are SQL data types. And what Hibernate has done is it's mapped our Java data types with SQL data types. And it's correct most of the times. You see here, you have address, which was a string in our case. It's a varchar 255, which works fine. Description is again a varchar 255 date. It was a date in our case, and it's converted it to a timestamp. So an ID, which was an integer, is converted to an integer. So this works fine for most of the situations. But what if you want to change this? You need more control over the data types that are created. So we will look at a few annotations, which helps us configure how the individual fields are treated by Hibernate. So the first annotation is something called as basic. So let me apply this annotation to the username field here. We'll call this at basic, and I can import basic from Java X.persistence again. Now, what add basic does is treat it as a field which should be persisted and apply the Hibernate defaults. Well, that's what's happening. Even without the add basic, what Hibernate did was it treated the field name as something that needs to be persisted, so it created a column for it, and it used the Hibernate defaults to create the data type in SQL, which can map to the data type of the field that we have declared. Now, what is the reason we use add basic? This is actually not required. By using the add basic, what we are doing is we are just telling Hibernate to just go ahead as it is. We would use add basic if you would need to configure a few other things. There are a couple of properties to the add basic annotation. One is the fetch, and one more is the optional. So these are ways in which you can configure while still letting Hibernate know that it needs to treat this field as a default. So that's when it makes sense to use the add basic. But without those properties, using add basic is as good as not having any configuration at all. So we will look at what those other properties are, but for now we'll just leave it as it is. So what we see is that if you do not enter anything, Hibernate automatically assumes that the field needs to be saved, and it creates a column for it. Now, what if I have a property in my class and I do not want Hibernate to save it? So there are a couple of things we can do. We can mark the property itself as a transient property. So if you have any transient or static properties in your class, Hibernate would not automatically persist it. The reason being, if you have a say username is static, so in that case all the classes will have will share the same username. So in that case, it doesn't make sense to have a column for the user table because every value for the username will be the same. That's a default configuration that Hibernate applies for us. If so what you can do is, if you don't want the username to get saved in the database, just mark the string as static or transient. Another way to do this is if you do not want to change the username string here, but you just want to tell Hibernate that this needs to be ignored. In that case, what you do is you add an annotation here called at transient. So again, I need to import transient. This will ask Hibernate to ignore this username field alone. So if we run this again, there you see the name has not been added to the insert statement because the name is not actually there in the columns. There you go, there's just 4 columns. Username is not one of them. So the best way to ask Hibernate to skip adding some fields by default is to just mark it as transient. Okay, we'll look at the join date now. Look at what Hibernate has done. It's taken the date property, the date data type, and it has mapped it to a timestamp without time zone. So what the timestamp will do is, if you just look at the data here, it has recorded the entire timestamp. It's recorded the year, month, date, and then of course the hour, minute, second, and millisecond. So this will it's going for everything. So it has all the data about the particular time, and that's the default. Now what if you just don't want to have the hour of the day, you just need the date? And this in that case this would not be required. You don't want Hibernate to save the timestamp itself, you just need Hibernate to save the date. So in that case, what you can do is you can add another annotation on top of the date declaration, and this is called temporal. Again, I import temporal. Now this temporal needs a property. Say I want to save only the date. I don't want Hibernate to save the time as well. So in that case, I would use the date. So it would select temporal type dot date. Temporal type is an enumeration, and it has these values: date, time, and timestamp. Now I'll save this, and if I run this, it will track only the date. It will not save the timestamp. I'm going to save it. So here you can see it saved only the date. Now if I want to save only the time and not the date, I would use the temporal type dot time, and of course timestamp is the default. If you do not enter the add temporal annotation, then it saves the entire time for a particular value, which includes the year, month, date, and the time from hour to millisecond. Okay, we'll have a look at one more annotation before we wind up this tutorial. Let's take the description here. Description is, let's say in my example here, it's a set of notes for the profile of this user, and let's say I can have as big a description as I want. I can write pages and pages of description. Now that might be a problem if it crosses this default value of 255. So in that case, I'm going to end up in an error. Now Hibernate by default uses this varchar of 255 for all strings, and this will work for most of the cases. But let's say I have a field where I want to use a huge amount of text, and I really don't have control over how long the text is going to be. So in that case, I use the annotation lob. Again, I will import from Java extract persistence. Okay, lob basically means that this is a large object, and most databases support large objects, and you can have two types of large objects in most databases. You can have a character large objects, in which case it's a clob, C-L-O-B, or you can have a byte stream, which is a large object, in which case it's a blob, which is a B-L-O-B. Now, by marking this as a large object, I'm telling Hibernate to choose one of these, whether it's a character lob or a byte stream lob, depending on the type. Now, if this lob annotation is on top of a string, definition, then Hibernate automatically assumes that this is actually a clob, which is it's a list of characters. And if the slob annotation is for a byte array, then in that case it chooses a blob. But we don't have to worry about that. If you feel that you have a huge amount of text or a byte stream, in that case you can use this at lob annotation to tell Hibernate to choose the corresponding data type in the database, so that we're not restricted to the 255 character limit that you would have if you had just chosen a string.